Time to start thinking about repotting these tomato seedlings. I started them about 4 weeks ago, and their roots are probably getting pretty bound up in this pot. They're not going to grow much larger, but they're not ready to go into the ground yet. I really need to think about giving this plant the best start. I really need to think about the living soil. Let's go ahead and take a look around the yard and dig up some soil and see if we can figure out what makes soil living anyway. What is living earth? Here's a spade of soil from a yard. Let's take a look and see if this soil looks like it has all the nutrients to replant my tomato plant so that they'll grow tall and strong and healthy and produce lots of fruit. What are we looking for? We're looking for evidence of fungi, actions of bacteria, decay, breaking down of organic matter. Do we see plant material that's breaking down? Do we see invertebrates, animals that are acting as decomposers in the soil? As we sift through the soil, do we have compacted hard soil or loose granules? Loose granules show us that there's evidence of active breakdown that the bacteria are doing, that materials are coming back into the soil and being recycled. In order for the fungi to thrive and live, we have to have oxygen in the soil, so there needs to be air spaces. When I hold the soil in my hand and squeeze it, is there enough moisture that some of the material comes together, but not so much that it packs tightly? These are all the ways that we can look at soil to determine if it has the living elements to support plant growth. Finally, you want to give it a smell. It should smell like the earth. It should smell like decaying carbon matter. It shouldn't be soggy or stinky. That would show that it doesn't have enough air circulation. I've collected some samples of soil from around my yard. I'm wondering which soil has the best chance at providing a good start for my plants. I know that I need living earth, but what does that mean? I'm going to examine each soil sample, look for evidence of life, look for evidence of decaying organic matter, and look for moisture and the ability of oxygen to move through the soil. I've covered the samples after I gathered them with this cloth bag because I know that if there are invertebrates in the soil, then they're going to move away from the samples with the sunlight. So now that I'm ready to compare them, I'm going to take the bag off. I have 4 samples. I have some soil from underneath my banana tree. I have some soil from a shade garden in my backyard. I also have some soil from the riverfront garden in my front yard. And finally, I have down here some store-bought or purchased potting soil. So let's go ahead and take a look at these soil samples. You can do this same kind of comparison at your own house with your own soil samples. Just gather a shovelful or a cupful, put it out on a piece of cardboard like I did, or maybe a piece of tarp or sheet outside in your yard, somewhere where you can take a good look at them. So let's go ahead and take off the cover now. First, I want to look at the moisture level and the color. I want to notice the different colors in the soil. I can see a deep brown color here in the river garden. I can also see that the particles are smaller. There seems to be a lot of moisture in the soil. When I gather it up and I squeeze it in a ball, I can see that it holds together tightly. That tells me moisture, and it also tells me that the particle sizes in this soil are small. I'm going to be looking for evidence of invertebrates, for small animals moving in the soil. So I have to pass it apart. I see some earthworms here. in the soil. I'm going to bury them up again. I see some evidence of some fungi living in the soil, these white threads. Now let's take a look at the banana tree soil. The particle sizes are much larger. I see lots of organic matter, little bits of leaves, twigs broken down that I can make out, some small pebbles. If I grab a handful and squeeze it, it doesn't form a tight ball. Some comes together, but not as much as the river, so probably less moisture, and also the particle sizes are larger and rockier. In terms of invertebrates, I also see some earthworm activity in this soil. So I've got some tunneling animals that are breaking down organic matter and opening the soil to oxygen and water to percolate or soak through from the above. Down here in the shade garden, if I look closely, I see more rocks in this sample. Also some leaves and twigs, so that's breaking down organic matter. That's adding nutrients to the soil and also air spaces. What if I do the ball test? Feels a little crumbly in my hand, a little crunchy, a little rockier. That probably means it's got good drainage. Water will flow through here well. Not as much activity going on with live invertebrates. So that might mean that the top layer where I got my shovel, my spade of soil, that the invertebrates are working below there. That might be because there's not as much moisture in the soil, so the organisms aren't coming up high. Now let's take a look at the store-bought soil. This is quite a different color, isn't it? It's kind of like an ashy gray color. And I don't see any evidence of invertebrates. I see some small bits of what looks like bark dust. And if I grab it in my hand, it's like paper. It doesn't hold together. It's very loose and very fine compared to the other soils. So we have river, banana tree, shade garden, and purchase soil. We've compared them on the basis of what we can see visually, how they feel in our hand. You can compare them by their smell. Where do you smell more organic material breaking down, more plants and dead animals rotting? And finally, we're going to do another test now to see which of these materials has more organic material, more carbons breaking down. We can do a simple test with something that most of us have in our first aid kit, which is hydrogen peroxide. So I'm going to go ahead inside and I'm going to grab some hydrogen peroxide and I'm going to grab 4 dishes so we can put a sample of each of these soils and test for the presence of carbon, which is an important component of living soil. All right, we're back inside now after comparing visually the different soil samples from around my yard. And I've gone ahead and just made a really simple data table where I can keep track of what I've noticed. What kind of moisture did I notice? What were the size of the grains? What happened when I tried to compact the soil in my hand? Where did I see invertebrates? What color was the soil? And maybe also I've noticed where was the soil rocky or fine, so things about the texture. You can add another column if you wanted to put specifically the type of invertebrates you noted. Really anything that you want to keep track of when you compare the different soils. So I mentioned that we're going to do a test now with the soils to see how they react to hydrogen peroxide. And the purpose of this test is to see where there might be carbon in these soils. And the carbon will be the result of the breakdown of organic matter in the soil. That's really important because organic matter that's decomposing into the soil is adding nutrients. So things like nitrogen and phosphorus and potassium and all kinds of other micronutrients. Also, the organic material improves the soil structure and keeps the nutrients from being washed away by rain before plants can use them. So it acts like a sponge. It helps to retain moisture in the soil and make it available for plants. So we really want to know if our soil is living earth then it's going to have high organic content or organic matter content. And we can test that to see where there's carbon as representative of that in the soil. So the reason why this works so well, I'm going to move my data table to the side. Here are my soil samples, store-bought. I'm going to go ahead and slide this over, it's a little bit more visible. I've just put it on a Lazy Susan tray that I had in my kitchen, but you certainly could just put this on a big plate, or you could put each soil in a separate glass bowl if you have. So you want to put it in something non-reactive. So glass is really your best, or thick plastic. We're going to be testing the soil as it reacts with this mixture, hydrogen peroxide, and that's H2O2, hydrogen peroxide. So this is highly reactive, meaning that it wants to combine and break apart, combine with other molecules or other solutions. And that's one reason why you always see it in a brown or opaque jar that sunlight can't get into, because the energy from ultraviolet light will actually start the peroxide breaking down. So if you had some of this out on your counter, or you put it in a clear jar, maybe you're going to take it out and bring it with you camping or somewhere where you might need for first aid. If you keep it in a clear jar where sunlight can get onto it, you're going to have free hydrogen and water after a while. So you want to keep it in this dark jar. Okay, so what we're going to notice is when we put the hydrogen peroxide onto the soil samples, we're looking for a reaction, and specifically we're looking for the production of carbon dioxide, which we're going to notice as gas, carbon dioxide gas escaping. Where we see a lot of reaction, a long reaction, we know that those soil samples are high in carbon, and that free carbon is reacting with the hydrogen peroxide. So when we add the peroxide, which I have some graduated cylinders here, I've measured 10 milliliters, 10 milliliters for each of the samples. So I don't imagine many people have little graduated cylinders at home. You can just use some small cups, and you want to have the same amount. Okay, you want that to be a control. So maybe 2 tablespoons. There's 2 tablespoons of soil here, or 1 tablespoon of hydrogen peroxide, but just make it the same. You want to control for that. So I've measured that out, and I'm going to put it right next to my 4 cups. I'm going to put it right here next to my soil samples. And as soon as I add them, it'd be great if I had 4 hands, but I'll do the best I can. I'm going to start the timer, because I'm interested in seeing not only if each soil has a reaction, but which soil has a reaction that goes on the longest, because that's going to tell me about the carbon in the soil. So I'm going to go ahead and add the hydrogen peroxide. I'm going to start the timer, and I'm going to ask you to observe with me, and I'll try to zoom in a little bit on the video so we can see what's happening. All right, so we're going to start, and I'm going to add my peroxide to my 4 samples. And I'm going to watch. And let's take a look at what's happening. You might notice, especially here, this river sample is really growing in volume. It's expanding. It's bubbling. If we come in close here, we can see bubbles forming and popping on the outside of this shade garden sample, but that river sample is really growing. I see a little reaction around the margins here of my store-bought mix, maybe some slight bubbling, but look at that gas bubbles being produced on the edge here of the river garden sample. Let's take a look at the banana patch. You see some bubbling here, some bubbling and popping. So let's take a look into the shade garden sample. And over to the river garden sample. Let's Still see some new bubbles forming on the edge. Nothing much forming anymore here on the store-bought sample. So I'm going to say at 1 minute and 40 seconds, the store-bought sample stopped bubbling. Still seeing active bubbles forming here. Okay, looks like Banana Patch is just popping now, so that's 2:15 on my timer. So we're still watching the Shade Garden and the River Garden. We want to see when we stop seeing new bubbles forming. So I don't see any new bubbles forming here at 2:38 in the Shade Garden. And now I'm going to be keeping my eyes here on this River Garden. So I'm looking to see if I see new gas bubbles forming on the sides. Still see some active bubbling down here on the margin between the plate. Okay, very low activity now, almost done. So we'll call it at 3:30, and I'll go ahead and stop my timer. And we can see really rather dramatically, if I come back out again, the changes. Really very few changes in the store-bought sample. A little bit of bubbling here, but the River Garden sample really swelled. So that also could be, remember how fine grained the soil was? So the hydrogen peroxide can coat or like form around each of the grains in this sample. So I think that might be one of the reasons why we saw so much reaction. So it's really holding the moisture. The Shade Garden and the Banana Patch samples, more reaction in the Shade Garden in terms of carbon. Also, these soils are a little less able to hold moisture. We know that from the ball test. Yeah, so maybe the peroxide ran through them a little more quickly. That might be one of the reasons to explain why we didn't see as much bubbling. But in terms of the carbon results, let's look at our timing here. Again, we're looking for the minutes and seconds of reaction time. So we can see the store-bought mix had very short reaction time. And similar for Banana Patch and Shade Garden and the River Garden, a long reaction time. So it took longer for all the carbon and the hydrogen peroxide to react with each other there. Okay, so this is I know that we have high concentration in the River Garden of carbon and relatively low concentration in the store-bought mix. This test is not going to give me a quantitative measurement. I'm not going to be able to measure the exact concentration of carbon. It's more qualitative, right? It's descriptive. I'm looking at bubbling. I attempted to quantify it by adding the time measurement. But there's other soil tests that you can do that will give you a specific readout for essential nutrients, okay? So this test is not meant to look at all aspects of the soil fertility or the living nature of the soil. But we have been able to do is make some visual observations about where we saw evidence of decay, so where we see bacteria working, where we're able to see invertebrates in the soil, and in some cases where the fungi are growing and spreading through the soil. And then we were also able to test for the presence of decaying organic matter, which we know is really important in living soils that are going to support plant life. So let's get back together and decide where to put those tomato transplants. Now that we have the results of our soil test, we have a better chance at giving this tomato seedling a start at a good, healthy life. So I'm going to go ahead and put it in a larger pot. I've added some of the soil that we got from the river garden that showed us from our test. That was good, healthy, living soil. And I added a layer of gravel on the bottom for drainage. And then I'm going to go ahead and put these new seedlings in and then add some more of that soil on top. So I'm just going to go ahead and hold it here for that to fall out into my hands. I'll keep some of the rocks behind on the bottom here. And as I'm doing that, you can see that the roots have gone and spread well here, and they're looking for someplace further to grow so that this plant can continue to grow. So we're going to give it that space. I'm going to separate it a little here in this pot, firm it down, and then go ahead and gently add the new soil around the edges. Break up any chunks as I'm going here. And break some of this up too. I'm just going to firm that up to help support the stem while these new seedlings are getting established in the new pot. And there we go. We're ready for our tomatoes to continue growing. What if you don't find any soil with good living attributes, with fungi and bacteria working on the soil to decay organic matter, or good moisture that will be held in a ball, or invertebrates in your soil? What can you do to improve your soil? Well, we can turn to old ways for that. We don't need to buy purchased soil. We learned from our test that actually the store-bought soil was not the healthiest living soil. So let's take one more trip out to the garden and look what we can do to help make our soil stronger if we don't already have strong living earth. Even if your soil isn't as rich in organic matter as you'd like it to be, even if there aren't many invertebrates in it, you can improve your soil. We can turn to some very old ways of thinking to learn how to do that. In Olelo, Hawaii, we say, "Mai kapai ikea o akamakua, aya he ola malaila." Do not set aside the teaching of your parents, for there is life there. In old times, and even today, wise people know not to throw away their yard scraps or food scraps, not to put them in plastic bags and send them to the landfill, but turn them into soil. So find a bucket or dig a pit that you can cover with a tarp, or make a space in your garden where you can start collecting your carbon and nitrogen-rich scraps to create compost that will lead to living, healthy soil. This bin in the garden contains vegetable scraps, clippings from the yard, straw and manure from the chickens, and it's very close to where I'm going to use it to support the life of the plants that support me.